Welcome to School of Computing. In this session, we will discuss various applications of stack data structure, and we also try to implement any one of the application as part of the case study or the use case. Stack is a very important data structure and is used in many real world applications. Few real world applications are listed here. Compilers. Every compiler internally uses stack data structure for expression evaluation. So irrespective of the programming languages, compilers internally use stack. This is one real-time example of stack applications. Operating systems. You all know that operating system is a software. It's a collection of programs. Operating systems also use stack in several places with respect to OS implementation. So there are many uh, use cases where OS internally use stack. Maybe it is with respect to scheduling, memory management, etc. etc. In not only stack, OS internally uses many data structures like queue also. Coming to browser history. Browser history is one live real-time example of a stack data structure. We all see how the browser history gets populated, and we see regularly how the URLs of our previous web pages gets populated in a last in first out manner. Every text editor uses stack. Wherever you find a undo button or a back button, right, whenever we press undo, the immediate previous action is undone, and again if I repeat it, its previous action is undone. So it's very much similar to our pop operation. So internally, all undo buttons and back buttons, wherever you find, they are again implemented with the help of stack. And the very famous programming concept called as recursion internally uses stack for its implementation. And of course, there are many other real world applications of stack. Some of the very common and popular applications we have listed here. And now we try to explore any one of this real world application. So, as part of the case study, we discuss the expression evaluation concept where compilers internally apply stack data structure. So, friends, expressions in programming languages are generally represented in the following form, like a into b plus c divided by d. This is the expression which we represent, and the very common notation is the operators sit in between the operands, like b plus c. So plus is the operator a, b, c, d. These are called as operands. Operand is nothing but the data on which operation is performed. So B plus C. So plus is sitting in between B and C. And the presence of parenthesis will tell that B plus C should be implemented first. So there is something called as precedence of operators, and we follow the precedence rule for expression evaluation. And the above notation is called as infix notation. So this is the notation which the programmers follow and they are comfortable in using it. But for processor, it is ambiguous. It creates confusion. Presence of brackets or parentheses leads to confusion, and hence the expression which is in infix form should be converted into an expression without any parenthesis. For that, we have two options. One is called as infix to postfix expression. Another one is prefix expression. So two types of conversions can be done. One is convert the given infix notation into postfix or convert it into prefix. So internally, compilers either convert an infix to a postfix notation or an infix expression to a prefix expression. In both postfix and prefix expressions, the parentheses are eliminated. Postfix, as the name suggests, the operators are pushed adjacent or to the right side of the operands, and prefix means the operators will come before the operand itself. Of course, there is a process. There are certain rules or guidelines for this conversion. So let us explore the infix to postfix conversion process now. Infix to postfix. I'll be just briefly explaining you the steps involved in this conversion. But until unless we solve one example of this conversion process, these statements will not be clear to you. So let me go through these statements. I'll try to explain, but after going through these statements, we will solve one expression, we will convert one infix to postfix, then the things will be more clear. So if we have an opening parenthesis, we push it to the stack. So friends, in the expression, wherever you find an opening parenthesis, you have to push it to the stack. If we have an operand, we append it to our postfix expression. So in this process, we will take two things. One is an output expression, or you call it as postfix expression. It's a string which is initially empty, and we use a stack. So what we will do is whenever we find an operand, we straight away write it to our postfix expression. And whenever we find an opening parenthesis, we will write it or push it to the stack. When we find a closing parenthesis, we keep popping out the elements from the top of the stack and append them to the postfix expression or output expression until we encounter the opening parenthesis. So we pop out the left parenthesis without appending it. Now coming to operator, if we encounter an operator, if the operator has, means whenever first time if you are seeing an operator, you obviously push it to the stack, but second time when the operator, one more operator is about to come into the stack, then the precedence rules will come into picture. So if the operator has highest precedence than the one sitting on top of the stack, we push it in the stack. So you should be little cautious while implementing these stack operations. So if an operator has higher precedence, for example, plus is an operator which is already sitting in the stack, and the next operator is a star, multiplication operator, then star can be pushed onto the stack without any problem because star has higher precedence than plus. But the reverse is not possible. If the operator has lower or equal precedence, if the operator has lower or equal precedence, then the one on top of the stack we keep popping out. Means, for example, if the operator sitting on the stack is a star and the incoming operator is plus. Plus has lower precedence, so it can't sit on top of star. So we have to pop out that star and add it to the expression. Then plus can enter into the stack. So this is the process. And when the last token of infix expression has been scanned, we pop the remaining elements from the stack. For example, my expression is completed, the last token has been processed, then whatever is left out in that stack should be popped and appended to our output expression. So friends, The summary is the process of infix to postfix conversion using stack is discussed and demonstrated. I'll be demonstrating it now with the example. One example we will take and we'll demonstrate it. So friends, this is the expression A into B plus C by D. This is our infix expression. Okay, this is our infix expression, and you find a stack there. So as part of the conversion process, we use two things. One is a stack and an empty string, which is my postfix expression. So this is my output string or postfix expression. So this is an empty string now. Now what is the process? Whatever steps we have discussed now, let me try to demonstrate and explain with an example. So we scan our expression right from the beginning. So whenever I find an operand, I'll write it to my output string. So I'll write A here. Okay. Then what is the next token or next element or character is a star. What is star? Star is an operator. So operator will go and sit in the stack. So I pushed it. Since this is the first operator, I am not worried about the precedence rule. Then after star, what did you find? You find an opening parenthesis. When you are dealing with opening parenthesis also, there is no precedence rule. Opening parenthesis can happily come and it can sit in the stack. After that I find B. B is an operand. So you have to write it, append it to our output expression. Then comes the plus. Now please observe, as per our infix to postfix rule, plus has less precedence than star. Then plus is not allowed to sit on top of star. But please note that rule applies to top of the stack. Means if plus is directly coming and sitting on top of star, then it's not allowed. But here there is an opening parenthesis on top of the stack. Star is not on top of the stack. So plus can be accommodated here. If opening parenthesis was not there, then plus will come, and if star is the top of the stack and if plus is coming and sitting on top of the star, then it is not allowed. You have to pop star. Now plus has been accommodated. After plus, what did I find? I find C. I'll write it. After C, what did I find? I find a closing parenthesis. Whenever you find a closing parenthesis, you don't push it to the stack like this. The rule is whenever you find closing parenthesis, you pop everything from the stack till you find the opening parenthesis. So in between closing and opening parenthesis, whatever operators are there, they will be popped one by one and you have to append them to the expression. Now in between closing and opening parenthesis, there is only one operator called as plus. I'll append it to the expression. Now what is the current status of the stack? Current status of the stack is we have only one element in the stack, that is star. We have only one element in the stack, that is called as star. Now what will happen after closing parenthesis? What is the next symbol? Next symbol is slash. Now can slash come and sit on top of the stack here? It's not allowed. It's not allowed. So slash has equal precedence than star. So the rule is only operators with higher precedence can come and sit on star. So I need to pop out this star. So star will be written here. Then slash can come into the stack. So the current position is star was popped and slash entered here. After slash, what did I find? I find an operator called as D, which is the last token, and my expression is completed. Now pop everything from the stack and append it to the expression. So only slash is there, that will be popped, and I'll write it here. This is my postfix expression. So friends, I hope you followed the process and the rules are clear now. And this process you need to implement using arrays and stack data structure. Then it will be considered as infix to postfix conversion program. So I hope the rules and guidelines given to convert an infix to postfix expression are clear, and you can implement this process infix to postfix conversion using C. Thank you.